Now we're going to talk about expressing sentences algebraically. This is perhaps the most fundamental thing that's being tested on the SAT math section, in my opinion. When you're writing an algebraic sentence based off of a written sentence, you can pretty much always write exactly what you see in the same order, with one exception, and the exception is subtraction. So as long as you don't see subtraction, you can pretty much write exactly what you see. In the first sentence, if Jim is J and Fred is F, then I can say Jim has 2 more than double what Fred has. In the second sentence, we have a number divided by 2. A number divided by 2 is 4 more than the number divided by 3, a third of the number. In the third sentence, 15 less than 12 is the square of a number. Now here, we see subtraction. So in order to subtract, you need something to subtract from. When I see 15 less than 12, that means that I had 12, and I took away 15 from it. So the exception with subtraction is whatever you're subtracting has to go afterward. And that is the square of a number. So if my number is x, it's the square of that number. And this sentence would actually never take place because no number, when it's squared, would come out to a negative number. Here's a problem from College Board's 2012 practice test. 10 plus x is 5 more than 10. So 10 plus x is 5 more than 10. From here we can solve for x. 10 plus x is 15 when we combine like terms. Take away 10 from both sides, x is 5. And they're asking us what's the value of 2x. Well, if I make this 2x, I've got to multiply both sides of the equation by the same thing, and 2x equals 10. And the answer would be C. Here's a problem from College Board's 2002 practice test. 1/4 of 4/3 is subtracted from 2. Now subtraction is the exception, so the 2 has to come first. I have 2, and I'm subtracting from that 1/4 of 4/3. What's the resulting value? That's 2 minus 4/12, and that could become 2 minus 1/3 after I simplify by dividing the top and the bottom both by 4. Now in order to add or subtract, I need the same denominator. So I'm going to multiply the 2, which is really 2 over 1, multiply it by 3 over 3, and I get 6 over 3 minus 1 over 3, which becomes 5 over 3, 5/3. Here's a problem from College Board's 2002 practice test. When a number x is subtracted from 36, 36 minus x, and that difference that we just created is being divided by x, so this thing that we created is being divided by x, the result is 2. What's the value of x? Here, one way to solve would be to multiply both sides by x, which would give me 36 minus x equals 2x. Now I can add x to both sides. 36 equals 3x. Divide both sides by 3, and x equals 12. So A would be your answer there. Here's a question from College Board's 2012 practice test. 3 more than twice a number is equal to 4. What is the number? 3 more than twice a number is equal to 4. What is the number? Take away 3 from both sides. Divide both sides by 2. And the answer is 1/2. Here's a question from College Board's 2012 practice test. 3 times a number is equal to 3 halves. 3 times some number equals 3 halves. I can divide both sides by 3. So dividing by 3 could also be called multiplying by 1/3. And I'm talking about it that way because I have a fraction on the right hand side. So therefore x equals 3 on the top, 6 on the bottom, which I can simplify down to 1/2. So the answer is B, 1/2. Here's a question from College Board's 2011 practice test. 13 added to 1/2 of a number, and the result is 37. Take away 13 from both sides. 1/2 x equals 24. Multiply both sides by 2, and x equals 48. And here your answer would be C. Here's a problem from College Board's 2011 practice test. Roy planted corn on 1/5 of his land. If he planted 45 acres of corn, how many acres of land does he have? One strategy that can make this type of problem a lot easier is to name your variable and tell yourself what that variable stands for. So x is going to be the total amount of land he has. Once I've created that, it's easy to say that 1/5 of his land came out to 45 acres. Now we can just multiply both sides by 5, and x equals 225. Here's a problem from College Board's 2007 practice test. Morgan's plant grew from 42 centimeters to 57 centimeters in a year. Linda's plant, which was 59 centimeters at the beginning of the year, grew twice as many centimeters as Morgan's plant did during the same year. How tall in centimeters was Linda's plant at the end of the year? The best way to solve a problem that's heavy on words is to lay out what you have so that you can visually analyze it. We have Morgan's plant. It went from 42 to 57. So if I want to know how far it went, that's 57 minus 42, which would be 15. Linda's plant was 59 at the beginning of the year, and it grew twice as many as Morgan's did. So it started at 59. Morgan's plant grew 15, so this one had to have grown 30. So if I add 30 to that, I get 89. How tall was Linda's plant at the end of the year? And the answer would be 89. Here's a problem from College Board's 2007 practice test. For what positive number is the square root of the number the same as the number divided by 40? If you're not viewing this problem as a matter of expressing sentences algebraically, it could get really difficult. If I call x my number, then the sentence is telling us that the square root of the number is equal to the number divided by 40. Now I can just solve this as a simple algebra problem. I can square both sides, and I have x equals x squared over 1600. I can divide both sides by x. I'm going to express that as 1 over x and 1 over x. Now the x's on the left cancel, and on the right we have this x canceling with this one, leaving us with only 1x. So when the dust settles here, we have 1 on the left and x over 1600 on the right. We can multiply both sides by 1600 and we get 1600 is the value of our x. So the answer would be 1600. The graph shows the amount of water remaining in a tank each time a pail was used to remove X gallons of water. 5 gallons were in the tank originally, and 2 1/3 gallons remained after the last pail containing X gallons was removed. What's the value of X? Each dot signifies a time that a pail was used to remove X gallons of water. That means that 1, 2, 3, 4, 5, 6, 7, 8 pails of water were removed. So I had 5. I took away 8 pails of water, and that left me with 2 1/3 gallons. And instead of P, I'm going to go ahead and call it X because they said that each pail had X gallons in it. So we can go ahead and just go through our algebra. We need to convert the right-hand side into an improper fraction. 2 times 3 plus 1 is 7, so it's 7 over 3. 5 minus 8x equals 7 over 3. Take away 5 from both sides. Negative 8x equals, now I need the same denominator in order to subtract on the right-hand side. So I'm going to multiply this by 3 over 3, and it's going to give me negative 15 over 3. So 7 minus 15 is negative 8. And we still have a denominator of 3. Negative 8x equals negative 8 over 3. Divide both sides by negative 8, which on the right-hand side I can call multiplying by 1 over negative 8. And now we have x equals, negative 8's cancel, leaving us with 1 on the top and 3 on the bottom. So the value of x is 1/3. Here's a problem from College Board's 2007 practice test. Marcus can spend no more than $120 on jeans and shirts for school. He buys 3 pairs of jeans at $32 each. If X represents the dollar amount he can spend on shirts, which of the following inequalities could be used to determine the possible values for X? Well, the total amount he spends on jeans plus what he spends on shirts has to be less than or equal to 120 because he's spending no more than 120. So he could spend 120 in theory. 3 pairs of jeans cost him $32 each. So 3 pairs of jeans that were $32 each, plus he's also going to spend X on shirts, and this amount has to be less than or equal to 120. So what we just constructed looks exactly like choice C. Here's a problem from College Board's 2004 practice test. Squaring the product of z and 5 gives the same result as squaring the sum of z and 5. So I have the product of z and 5, and I'm going to square that. And that gives us the same result as squaring the sum of z and 5. So I'm going to square the sum of z and 5. Which of the following equations can be used? What we just constructed here looks exactly like choice D. Choice A is tempting, but in choice A, if we were to actually square the 5z squared, the 5 would stay 5. But in choice D, when we square the left-hand side, it would come out to 25z squared, which would be correct. So the answer is D. Here's a question from College Board's 2004 practice test. When a certain number is multiplied by 1/4 and that product is then multiplied by 32, the result is 60. What is the number? 32 over 4 is 8, so 8x is 60. Divide both sides by 8, and x is 7.5. Here's a problem from College Board's 2002 practice test. There are 20 packages of bagels on a shelf in a store, and each package contains the same number of bagels. 3 of these packages contain 18. How many bagels are there in 7 of the packages? Well, if I have 3 packages, and there's a total of 18 and they're spread evenly, then there's going to be 18 over 3 in each one. So 18 over 3 is 6. So now we know that there are 6 in each package. So how many are in 7 of the packages? Well, I have 6 in each, and there are 7 of them altogether. So 6 times 7 is 42. So the right answer there would be D. Here's a question from College Board's 2002 practice test. I have a number. I'm going to add 3. Then I'm going to multiply what I have by 4. Then I'm going to subtract 6 from that. I'm going to take what I have, and now I'm going to divide that by 5. And C perfectly matches what we did here. Here's a problem from College Board's 2004 practice test. On Monday morning, Mr. Smith had a certain amount of money that he planned to spend during the week. On each subsequent morning, he had 1/4 the amount of the previous morning. Saturday morning, 5 days later, he had $1. How many dollars did Mr. Smith originally start with on Monday morning? Like I said earlier, on a heavy, wordy problem, the best thing you could do is visually lay out the information that's been given to you. So we have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. On Monday, we started with some amount. Each day, we had a fourth of what we had the previous day. So x times 1/4 is 1/4 x. 1/4 x times 1/4 would be 1/16 x. 1/16 times 1/4, 1/64 x. And 64 times 4, 256. So 1/64 x times 1/4 is 1/256 of x. When we multiply 256 by 4, we have 1 over 1024x. So on Saturday, he had $1, and Saturday is also 1 over 1024x. So 1 over 1024x equals 1. To solve for x, we would multiply both sides by 1024, and x equals 1024. Here's a problem from College Board's 2007 practice test. Connell had a box of 36 candy bars to sell for a class fundraiser. He sold 10 of the bars on his own, and his mother sold half of the remaining bars to her co-workers. No other bars were sold. What fraction of Connell's original 36 bars remain unsold? So he started with 36. After his first sale, he had sold 10 candy bars, so he was left with 26. His mother sold half of those to her co-workers. So his mother sold half of the 26, so she sold 13 to her co-workers. No other bars were sold. What fraction remained unsold? So we started with 36 then it became 26, and 13 of those were sold. So right now we're left with 13. Now, what fraction of the original 36 bars remain unsold? Well, a fraction is just a part over a whole. And here we're talking about 13 out of the original 36, which would be the same as the answer in D. Now we're talking about differences. Differences are important because if I want to know how much greater something is than something else, I can just take the larger number and subtract the smaller number. Also, if I want to know the distance between two things, I can also take the larger number and subtract the smaller. If I wanted to use absolute value, I could subtract the numbers in any order I want and then take the absolute value later, and the answer will always be positive. But if you don't want to get involved with absolute value just yet, just know that you should always subtract the bigger number from the smaller number from the bigger number. If 7x is 24 more than x, 7x is 24 more than x, x squared is how much greater than radical x? Well, first let's solve for x. Take away x from both sides, 6x equals 24. Divide both sides by 6, and x equals 4. So I want to know how much bigger x squared is. So I've got x squared, and I want to know how much bigger it is than radical x. So when we want to know how much greater, we just subtract bigger minus smaller. I know that x squared is going to be bigger than radical x, especially for positive numbers, you know that kind of thing for sure. So here, if x is 4, x squared is 16, and radical x is 2. So if I want to know how much bigger, it's just 16 minus 2, and the answer is 14. So the right answer here would be C. Here's a problem from College Board's 2001 practice test. In the increasing sequence above, the first term is y and the difference between any two consecutive terms is 3. What is the value of the fourth term in the sequence? Well, if the difference between any two consecutive terms is 3, that means that if I take the second term and subtract the first term from that, and I know because it's increasing that the green part there is the bigger one. So 2y plus 7, when I have that and I take away y from that, the difference is going to be 3. So 2y plus 7 minus y equals 3. Combine like terms, y plus 7 equals 3. Take away 7 from both sides, and y equals negative 4. So now that I know that y is negative 4, I know that this here is negative 4. I know the next term is negative 4 times 2, which is negative 8 plus 7, negative 1. I know the next term is negative 4 plus 6, which would be 2. The difference between any two consecutive terms is 3. So going from negative 4 to negative 1 is a difference of 3. From negative 1 to 2 is a difference of 3. And if we want the next term, we would just increase by 3. So the answer would be 5. Here's a problem from College Board's 2012 practice test. T is a number greater than 1, then t squared is how much Here's a problem from College Board's 2012 practice test. If t is a number greater than 1, then t squared is how much greater than t? Well, if I want to know how much greater t squared is than t, mathematically that's t squared minus t. The difference between them will tell me how much greater the bigger number is. Now, a lot of the time on the SAT, when you're in a bind, you can look at the work you have in front of you and just say, if I were just on any kind of algebraic problem, what would be the logical next thing to do, or what are my possible things I could do here? When I see t squared minus t, I'm thinking that I can kind of possibly factor t out of both of those. If I did that, that gives me t times t minus 1. And that's your answer, D. Here are some problems on assigning multiple variables in word problems. When you're assigning variables, the best thing you can do is write down what your variables stand for. Here's a problem from College Board's 2001 practice test. Wayne would like to buy a school jacket priced at $81, but the price of the jacket is $59 more than he has. In which of the following equations does X represent the number of dollars he has? If X is how much money Wayne has, maybe we can say that Y is the price of the jacket. Now, the price of the jacket is $59 more than the amount of money that Wayne has. We also know that the jacket costs $81. So I'm going to go ahead and just put 81 in for the price of the jacket. And 81 equals 59 plus X. If that were one of the answers, I could select it. But none of the answers look exactly like that. So I could take away 59 from both sides. And I could take away 81 from both sides, just to kind of move things around and see if I can get an answer that'll match the answers that are there. When I do that, I have X minus 81 equals negative 59. And that would be the same answer that we have in choice D. Another way of reiterating the answer in choice D is that if Wayne took the amount of money he had and somehow bought the jacket even though he didn't have enough money, it would drive him negative because the jacket cost $59 more. So if he subtracted 81 from what he had, he would go negative 59. So this would almost be what would happen if he were to buy the jacket with a credit card. That was more than the available balance on the credit card, and it might go $59 beyond its balance. Here's a problem from College Board's 2004 practice test. If notebooks cost $2 each and backpacks cost $32 each, which of the following represents the cost in dollars of N notebooks and B backpacks? Well, if I were spending money on notebooks, N is the number of notebooks, and each of those costs $2. And B is the number of backpacks, and each of those costs $32. So 2N plus 32B is the total money that we'd be spending. And that's what we have in choice D. Here's a problem from College Board's 2001 practice test. How many 1/4 pound sticks of butter weigh as much as 25 pounds of butter? If X is the number of sticks of butter that we would need in order to get 25 pounds, I could say that the weight of one stick multiplied by the number of sticks would give us 25 pounds altogether. Now I can multiply both sides by 4, and X equals 100. Here's a problem from College Board's 2001 practice test. Two numbers have the property of their sum is equal to their product. One of the numbers is 6. What's the other number? So X and Y can be my numbers, and their sum is equal to their product. If one of the numbers is 6, I'll go ahead and say that X is 6, so 6 plus Y equals 6Y. Now I can just take away Y from both sides. 6 equals 5Y. Divide both sides by 5, and Y equals 6 over 5, 6/5. Here's a problem from College Board's 2002 practice test. One adult and 10 children are in an elevator. If the adult's weight is 4 times the average weight of the children, then the adult's weight is what fraction of the total weight of the 11 people in the elevator? If I say that X is the weight of the children, then I can go ahead and say that 4X, and that's the weight of each of the children. I can say that 4X is the weight of an adult. Now, if I want to know the fraction of the total weight that one adult is, then a fraction, as I said earlier, is just a part over a whole. And one adult is equal to 4X. And the total weight on the elevator is 10 children plus 1 adult. And the adult is 4X. So to simplify that a little, we have 4X on the top and 14X on the bottom. The X's are going to cancel. That leaves us with 4 over 14. Divide both sides by 2, 2 over 7. And so the answer would be 2/7.